Okay, today's we're going to do paying off a loan. Now, this topic is very similar to the superannuation, where we're going to use a GP formula to actually do the calculation. It is a bit tricky, when it comes to the loan repayment question. You have to make sure you read the question very carefully, and then you need to change the units around. Does depend on whether the question tells you it's compound monthly or compound yearly. I'm going to start with a few examples, and hopefully through the examples you understand how to do the question. Concept itself, it's not that hard. It's quite easy to understand. You just need to be able to actually set up your formula, and then you derive the formula from scratch. Okay, all right. So let's start with an example one. All right. So for example one, let's just say I want to borrow 1 million to buy a property. Okay, so I want to borrow 1 million, okay, to buy a property, and the current interest rate is let's just say 4%. Okay, so interest rate is 4% per annum. However, it's compound monthly. So these are the information about the question. Okay, compound monthly, and then the mortgage term is 30 years, so n is equal to 30. So I'm going to repay those amount of money within 30 years. So n is equal to 30 years. All right, and the question is you need to be able to calculate how much is my monthly repayment. Okay, so calculate. Okay, calculate monthly repayment. All right, so here's the question. A very typical loan repayment question here. All right, so how would you do this question? I guess the first step you do is you sort of need to set up your equation properly. So I'm going to draw sort of a timeline to actually show you what's going on with the loan repayment sort of questions there. So let's just draw a timeline here. All right, so this just representing different number of periods. Okay, it could be year, it could be months, could be every half year, depends on the question itself. So in this case we're just talking about a month, right? Since this is like a month's repayment, and also the interest rate rate is also compound months. Interest is also charged monthly as well. Okay, all right, so let's have a look. So at the beginning of the first month, right, you borrowed 1 million. All right, and then usually the repayment, or you start to repaying the loan 1 month after when you're taking it out. So you don't really just repay straight when you borrow $1 million. So you repay after the one period of time. In this case, it's 1 month. It could be like a 1 quarter, 2 weeks, 1 fortnight. It does depend on the terms and condition, but usually it's just 1 month later you pay the loan. But then think about this. All right, you borrow the $1 million, right? At the beginning you borrow $1 million, but during this period of time, like this is 1 month period, bank is going to charge you the interest. Okay, so you're not going to just pay off 1 million for the first payment, because what you're thinking about is I borrow $1 million, then after 1 month or after 1 period, the bank already charged you the interest. All right, so in that case, what really happens here is at the end of the first month. Okay, so at the end of the first month, you're gonna have that $1 million plus the interest. All right, plus the interest. That's how much you need to repay. That's how much you still owe to the bank now. All right, so it's not 1 million. It's actually 1 million plus the interest before you make it the first repayment. Then you start to think about, okay, now I need to repay. Okay, so you need to minus the repayment. And it will be either monthly repayment, quarterly repayment, fortnightly repayment. Does depend on, again, the question. So you have to be very careful when you're reading out the question. Okay, so then in that case here, we're going to call the A1. It will be the amount you still owes to the bank at the end of first period. It can be first month, all right? So that's you still owes to the bank after the first period of time, and that's what A1 is. So if you follow this idea, okay, A2 will be the amount you still owes to the bank at the end of the second period, the second month, the second fortnight. Again, depends on the question. A3 is the amount you still owe to the bank at the end of the third one until you get AN. All right. And obviously, when you're repaying the loan, or you want to make sure that AN is equal to 0, because you want to repay all the money, including the interest and everything, to the bank. All right. So let's derive the formula based on this. Since we already know that A1 is the amount of money you still owes to the bank, okay, and A1 is equal to the amount of money that you borrowed, okay, so amount borrowed, okay, plus the interest minus the repayment. Okay, so based on this formula here, the amount of borrow is 1 million. So in this case, let's just say P, just become, make this maybe easier, okay? And we'll just let P to be the amount that's borrowed, okay? And we can do the substitution later. All right, so P, this is the amount that you borrowed. The interest, okay, so we need to obviously find the interest, okay, for like just one period of time, right, for 1 month in this question here. So it's going to be a compound interest question. So P and then bracket 1 plus R, that's the interest rate to the power of 1. It's 1 period, 1 month, and remember the R in this case is compound monthly, so it will be a monthly interest. Eventually later we're going to change that interest rate from 4% to the monthly interest. So we're going to deal with this one a bit later. All right, what I'm doing right now is just deriving a formula. Okay, so what happened here is this is amount borrowed. Okay, this amount borrowed plus the interest is the P bracket 1 plus R to the power of 1. Okay, then you need to minus the repayment minus the M. So let's just let the repayment to monthly repayment to be M. Okay, M is just how much that you repay. It can be a couple of $1,000, depends on whether you can repay like $1,000 or $2,000, but you can do the calculation and we can find out if I want to pay off the loan within 30 years, how much I need to pay every month. All right, so the repayment is just going to be M. All right, so this is A1. All right, that's what A1 is. A1 is how much you still owes to the bank at the end of the first period after the first repayment. Okay, now if we follow this method, all right, if we follow this pattern here, A2 will be the amount you still owes to the bank plus the interest minus the repayment. So this is the amount that you still owes to the bank, which is from A1, right? So that's, I'm just going to write A1 here. So that's A1. And then you need to make sure that you plus the interest again. All right, and then minus the repayment. The repayment is going to be the same, all right? It's going to be a fixed amount of payments each period of time. So in that case here, the way to calculate A1 and interest this time is pretty similar to the one we did before. This is how much you still owes to the bank at the end of the first period, right? And then we're going to times this one by 1 plus R because, and that'll be, you accumulate during the 1 month again, and during 1 period of time, there's an accumulation of interest again. All right, so minus the repayment is M again. So at the end, as you can see, there's a pattern. All right, after you expand, you get P bracket 1 plus R to the power of 2 minus M 1 plus R to the power of 1 minus M. All right, so if you follow this pattern here, the A3 is just going to be A2 plus the interest minus the fixed repayment. And in that case here, it will be P bracket 1 plus R to the power of 2 minus M 1 plus R to the power of 1 minus M. Now remember, this whole amount, okay, is the amount of money you still owe to the bank. Okay, so right now, this representing A2. So if I want to plus the interest, all I need to do is attach 1 plus R to the power of 1 again. Okay, this is just simply because of the compound interest. All right, now if you expand that, now that gives you P bracket 1 plus R to the power of 3 minus M 1 plus R to the power of 2 minus M 1 plus r to the power of 1. Now, don't forget that we still have to minus the repayment. So at the end, we have to minus m minus m. So hopefully now you realize there's a pattern here. So if that's a 2 here, that's a 2, that's a 1, and then imagine this is 1 plus r to the power of 0. So if that's a 3, that's a 3, 2, 1 in descending order, and then that's power of 0 here. Okay, so in that case, we can sort of derive a formula for an. So an becomes p brackets 1 plus r to the power of n minus m 1 plus r to the power of n minus 1 minus m 1 plus r to the power of n minus 2, and then keeps going, all right, until that you minus m, and that's it. So in order for us to actually derive in a GP formula, then what we need to do is you can factorize this part of the terms out, okay? So you can sort of like group those parts, all right? So putting a bracket and make sure everything is plus inside, and then you can change the order. So, you know, instead of this descending order, you can make that into ascending order, so it's easier to form in a GP formula. So that's what you can do. So that's what I'm doing right now, okay? So I'm going to form a bracket, and then I'm going to start with m and put m in the front. So m. And the second term will be m 1 plus r to the power of 1. And it keeps going. 1 plus r to the power of 2. And dot, 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 dot. 1 plus r to the power of m minus 2. And the last one is m 1 plus r to the power of m minus 1. So the last term is actually as a power of m minus 1. You just have to be very careful about this. Now, of course, you can take the m out. You can factorize the m, you know, out as a common factor if you want to, but I'll just leave the inside. It doesn't really change anything, okay? All right, now, with all of the terms here, let me just highlight this part. With all of the terms here, this is a typical, you know, example of a GP, a series of, you know, a GP, okay? So what we need to do is we need to find the sum of this GP here. Okay, find the sum of GP. So all of those, oh, that's terrible. All of those is the sum of GP. Okay, all right, so how do we derive a formula for GP? So what we need to know is what's the A, what's the first term, what's the common ratio, and how many terms we have there. All right, so let's just do it on the next page. I'm just going to copy this one to the next page. Oh, oops. Okay. All right, so now let's start from this page. All right. Let's form a GP. Okay, so in that case here, if you think about this, the leading term A is equal to M. That's what the leading term is. The common ratio. Now, the reason I write the common ratio in full words like this is just because if you're using R, sometimes you get confused about this R with the interest rate. So you probably just write on a common ratio if you want to, or you can use lowercase r. So the common ratio is 1 plus R. See what I mean? All right, you've got two R's in the same line of equation here, so it's try to avoid a problem using different R. The N is the number of terms, all right? How many terms we have there? So let's have a look at N. How many terms we have? If we do the counting, this is a bit tricky as well. This is this is 1 plus r to the power of n minus 1. So when people look at n minus 1, they're thinking about, oh, there's an n minus 1 of terms. But then you also need to think about there's an additional terms in the front here as well with no attachment. So in that case, and the power is actually equal to 0. So if you do the calculation, n minus 1 minus 0 plus 1, that kind of form, you should be able to find out there are n number of terms. Okay, so n number of terms. All right, so once you know this, the sum of GP, so Sn is equal to, we know the formula, that is A brackets 1 minus, or R minus 1, using lowercase letter, R minus 1, Rm minus 1 over R minus 1. Okay, so therefore in that case we just have M bracket, the common ratio here is 1 plus R to the power of n. We do have n terms, minus 1 over 1 plus R minus 1. So at the end, you've got m bracket 1 plus r to the power of n minus 1 over r. All right, so this is what you have here. To replace what's inside for this bracket. Okay, all right, so let's rewrite it. Now we have that an is equal to p bracket 1 plus r to the power of n minus m bracket 1 plus r to the power of n minus 1 over r. Okay, so here's the formula. Now, please never memorize the formula. In exams, you're going to be asked to derive this formula. So you'll be given questions. So usually you'll be given questions where they break the question, break the question into 3 parts. Part A, find A1, A2, whatever. Okay, part 2, part B, they ask you to derive AN or show AN is equal to this kind of formula with numbers in it. And the last part will be something like, to solve the question and take, they ask you about what's the monthly repayment. They can also ask you about what is the interest rate, could be the interest, all right, that's charged over the 30 years period of time, or how long it takes, all right, to repay all the money if you change the monthly repayment from certain amount to another amount. So there can be variations for question, but never ever remember the formula. All right, so here we go. Now we need to solve the question. We need to find out what m equals to. All right, so I'm just using a different color for m so you know what we are solving is for m. All right, the monthly repayment. Okay, so let's have a look. Now, what we need to do is we need to let an equal to 0. All right, remember I need to repay everything. The principal I have here is 1 million. That's how much I borrowed. The current interest rate for my memory is 4% per annum. But what we need to do is we need to divide it by 12. So we get per month. All right, so that's interest rate per month. All right, because the interest is charged, compounded monthly. So that gives you 1/3% per month. All right, what else we have? The n. N is number of terms. So n is 30 years. But then the common unit here is months. So we need to times 30 by 12. And that gives you 360 months. Okay, all right, so we've got all the information here. All we have to do now is substitute everything into the formula that we derived before. Okay, so we have, let's just highlight this, an, which is equal to 0, an, which is equal to 0. We have the p, the principal, that is equal to 1 million. We also have that r, the interest rate, which is 1/3%, and that's interest rate. And the last one, we also have the n, the number of period of time, which is 360 months. All right, so the remaining calculation is just back in a basic calculation to your calculator. All right, so 0 is equal to 1 million bracket 1 plus r to the power of n, 360, minus m. Now, it's better to actually just group this as one single group, all right? Because what you can do is use your calculator, work out this group here, so you don't have to worry about that, long calculation. A few students find it, it's a bit annoying because of the numbers is really large and they kind of using the calculator incorrectly as well. So they make silly mistakes, okay? But if you just treat this as like one single group, do the calculation on this side first, okay? Do the calculation here, and you just do division. So that should be quite easy. All right, okay, so let's do the calculation. M is equal to 1 million 1 plus 1/3% to the power of 360 divided by everything here. All right, so I'm just going to copy this one a bit easier so I don't have to write it. All right, oops. Also copy the highlighted part as well. That's all right. Just remove the highlighted part. Yep, perfect. Okay, all right. Let's use our calculator and let's find out what's the answer. Okay, So let's just do the calculation on the top. Right, so the numerator is equal to this number here. Make sure that you also store your numbers in your calculator so you get a very accurate result. All right, do not do the rounding. Save the save the answer in the calculator so you get a very nice and accurate result. All right, so I'm just calculating the next one. All right, and the answer is that. All right, let's hope my calculation is right. So if my calculation is right, and if we do division now, the answer will be, yeah, that is the right number, 4,774, roughly this amount per month. Okay, that's how much I have to pay. By the way, this is my question. I borrowed like over $1 million to buy properties, and current interest rate is roughly about like 4%. So this number, I have to repay about like $4,700, each month. Pretty much very accurate, I guess. All right. Okay. Now, that is what we need to do for the loan repayment question. So from here, they can ask you various questions. They can ask you how much interest. All right. So like, what is the interest? So they can ask you certain questions about like calculate the total interest. Okay, they can also ask you questions about like, if you increase your monthly repayment, so right now the monthly repayment, if you increase monthly repayment by a certain amount, like currently 4,774, but however, like let's say I want to increase to $5,000, and then they ask you how long you can save, okay, how much interest you can save, and then because if you pay this amount, it took you 30 years to repay them, repay the entire amount. But if you increase the monthly repayment, obviously the number of period of times reduces as well. So they ask you about, okay, how much interest you saved, okay. And this is sort of like a real question, right? If you do have spare money, you want to repay a little bit extra each month, and you're saving interest by, basically you're saving interest. But in the reality, like a certain bank, they've got some terms and conditions. They don't allow you to actually repay more. So even you do have money, you can't really repay extra just because they want to get some interest from you guys. Okay, now another type of question would be if you want to reduce the terms, so you don't want to repay like within 360 months, you want to finish off the loan in 25 years. They ask you about, okay, so if you want to reduce the N, how much you have to pay for the monthly repayments. So this type of questions there. Okay, now those questions are not really hard at all. All you have to do is change the numbers in the formula here, okay, around, and start to solve the equation. So it's not a really hard question to deal with at the end. You definitely need to try a few questions to get a hand of it. All right, otherwise it's actually pretty easy. So I'm just going to do one. Okay, so calculate the total interest. So in order for us to calculate total interest, it's actually quite easy. So this is how much I repay each month. You times this number by 360. That's the total amount of money that you actually pay. So if you times by 360, this is how much I will pay for 30 years. Okay, and then think about this number here. Then the total interest, it's quite shocking. The total interest is going to be this number minus 1 million that I borrowed. So it turns out that the interest, sorry, it's not 1 million, but it's almost going towards 1 million. So it's like a 718,695. Okay, that's an extra that you pay to the bank. Didn't double, but I would say close to double. Obviously, right now the interest rate is 4%. Imagine if the interest rates increase to like 7%, 6%, then the total interest is definitely going to be the same as the amount you borrow, or even more. Yeah. Okay. Okay. All right. So a recap. The most important thing about this exercise or this topic is be able to derive, all right, the formula from scratch. And you do definitely need to read it carefully, read the question very carefully. Just because when paying off the loan, the first repayment is usually made 1 unit of time after the loan is taken out. But sometimes the question can be changed. It can be tricky. They will say, okay, after a certain period of time, then you pay the first payment, or even as immediately after you take the loan, you pay the payment as well. So you do have to change the end. All right, slightly depends on the question. Do also pay attention to the compound monthly part as well. It could be compound yearly, compound half yearly. So you do need to change the unit according to that. Then once you know how to derive those formula, then the hard part is be able to substitute the numbers correctly, and use your calculator properly as well to find out the final answers there. All right, so I hope you're enjoying the lesson here. Thank you. Thanks for watching.